So this is the sixth lecture. We're going to talk about some more tips and then talk more about prompt engineering, generative AI, crew AI, and we'll continue our conversations here. Let's recap all the things that we've done so far. First thing you guys learned in the first class, how to use Windsurf, and we have been doing these vibe coding assignments every week. So this is your sixth week's assignment. It's called Lead Gen, which I think is going to be pretty interesting. Last week, you created an assistant for HR to help your fellow Johns Hopkins students find jobs. Prior to that, you had the equity research AI, where you were given 3 earnings announcements. One from, I think it was NVIDIA and Amazon and Google, and you're supposed to try to analyze from a value investor perspective which one you would like, and then also from Cathie Wood's growth perspective. Prior to that, you had an assignment, I think probably the most difficult one, which is Flying Blind. I just gave you some folders with a bunch of data. And then before that, you had, how do you screen people at the border? Because we had a hypothetical situation, just kind of fun. Elon got fired, and then you were put in charge to do that. Okay. And your first Vibe assignment, as you remember, was the Snake Games. So let's move on. Next week, just to be clear, is going to be one-on-one meetings with me. I want to make sure that you guys are progressing well for your final presentation. That will be we'll talk about sort of the requirements a little bit later. But so we have this lecture, the 6th, and then next week we'll do the one-on-one meetings with me, and then your final will be done at in 2 weeks from now. Okay. So Lead Gen is this assignment where you're going to use vibe coding, and you're going to figure out a way to generate leads for a particular company. Here we're just using SoCatAI.com. For any company, what you should do whenever you think about generating leads for them is first, what does that company do? What is the mission of the company, right? So, take a look and see what you can glean from this. The other idea here is, how can it be most useful? So throughout this whole course, we've been talking about how do we add value to companies. So can we qualify these leads? Who would be the most interested sort of potential customers? So can you get in the position of the entrepreneur or this business owner? Can you also get into the mindset of a potential customer and try to think, what kind of business problems exist, right? So you're going to use Windsor or Cursor, whichever vibe coding platform you like, and you don't have to just use those two. You can use whichever one you want, and you will try to create a process in order to find leads for this particular company. As always, you'll make a 3-minute video and you'll share it with your friends in the discussion boards. Now, what I want you to think about is how can you make this very general? So the idea is, yes, you're given one particular company, but could you have, any company's URL? Suppose you put any company's URL. Could your lead gen work for that? That's the advanced challenge. If you can pull that off, I think it opens up a lot of really interesting conversations, especially if you have to go interview with one company and they have a publicly facing website. You can go and say, oh, I got a list of leads here. Would this be of interest to you? And you also know the company's mission, and you will have thought through how to add value from the perspective of the entrepreneur of that company, but also from the potential customer. Okay, as always, you just do your best, which is all that Professor Liu can require from you guys. All right, let's go. Today we're going to do a couple of things here. There's a couple of documents. One is a practical guide to building AI agents. This is from OpenAI, so we'll look through that. There's another video here. These are vibe coding tips from Y Combinator, which is a famous accelerator out on the West Coast, and a lot of their Y Combinator companies that have been applied and accepted are using vibe coding to sort of create their product and businesses. So a few of those entrepreneurs are sharing their tips, how they're using vibe coding. So I think that's going to be helpful for you for your final project. We'll do an introduction to Crew AI, and then you have your assignment 6, Lead Gen, and then I'll give you some tips for the final project, and also some tips on prompt engineering. So in this document, A Practical Guide to Building AI Agents, I think it's pretty interesting because, here are some sort of tips. So one of the questions and answers in this document is, what is an agent? When should you build an agent? What about agent design foundations and guardrails? So I encourage you to read this. It will be inside the Canvas folder for everyone. So what is an agent? Well, we've had this conversation many times. An agent, according to them, is a system. Agents are systems that independently accomplish tasks on your behalf. So the idea here is some kind of software system that will do something, right, independently, right? And what can an agent do? It can use tools, it can search the external environment, it can bring things back in, it can sort of reason some more. If it has enough information, it may go out and use another tool, and it can even choose which tool to use, and then also decide at what point are you, quote, finished with the task or the goal. So the distinction between agents and chatbots are very important. When I say chatbots, I mean, when first ChatGPT came out, I'm sure by the time, a couple of months from now, chatbots are going to be very advanced, probably using tools, so it'll be difficult to distinguish between an AI agent and a chatbot. But just to recall, think of the early days of ChatGPT, where you would write in a text prompt and it would respond with a text answer. The chatbot, ChatGPT, the first couple of iterations, had no ability to go out there and execute code. However, it did have the ability to generate different types of code. But again, that was just text, right? So an agent can actually take that code and then, spin up an operating system, put that code in and execute that code. It may run, it may not run. If it doesn't run, there will be generated a log file of errors, and an agent can take those errors and the original code and try to debug it. And this is exactly what's happening in your Windsurf as you guys are sort of trying to solve these challenges. Okay. Another way to think about this is from the prior class, we had this very nice framework where the agent's in the middle, and above it we learned about memory and short-term and long-term memory. Remember, the short-term memory is in the buffer, and the long-term memory is sort of saved to the file, right? We also discussed about planning. So what is planning? Well, a chatbot can sort of reflect, do chain of thought, right? Let me think about this step by step. It can criticize the results of the answers. Obviously, it can change the tone, whatever it may be, from conversational to academic or so forth of these things, and also delegate, sub-goals decomposition. So who should do what, right? So when you think of chatbot, think about the right-hand side, and it's kind of limited to that, right? And remember the early days of ChatGPT. Now, when you think about agents, think about the left-hand side, where you have agents pointing to tools and also actions. So an agent, right, can reach outside its environment and actually get information. So in the early days of LLMs, they would train these LLMs, and it would cost, 10 million, 20 million, hundreds of millions of dollars. So the information inside that was pre-trained would get stale. And people wanted the LLM to have access to the current information. So what did they do? Well, they built a tool, an API, to reach out to the current news and pull information back into the LLM. So one really simple example is, what's the weather like today? So if this LLM was trained a month or two ago, pre-trained, it would only have that information. But if it could use a tool, it could reach outside and say, for today, what's the weather in whatever location, Baltimore, DC? And then it could bring that information back in, and then it could do something with that information. For example, maybe if it's going to rain, it tells you, hey, maybe you should need an umbrella. And in the early days of LLM, they're notoriously poor at math. So another tool could be, hey, can you use this particular calculator? Wolfram Alpha, and they had some really good math tools, and there was a lot of APIs and some interest in incorporating other tools outside of the LLM in order to help with the math, if it could be identified as a math problem. So there are many different tools. Search we talked about a little bit. The calculator. You can do the weather. Also code interpreter. So remember the LLM will generate some Python code, and now with the tools and actions, you can actually run those code and run the code sort of locally. And then however the code responds, if there's an error, then it's stored in the log files. So the LLM could grab that log file, which is just text, and bring it back in with the code and try to debug the code. And that's exactly what's happening in your Windsurf. So, I think this is a nice way to compare and contrast the chatbots versus the agents. But I anticipate that, in a couple of months, the chatbot on ChatGPT will be able to do more and more in terms of using tools, because now you're starting to see it reach out, do web search and so forth. And it can also do some research, which it will pull in articles and start understanding those articles. So I imagine, as we move forward into the future, it's going to be a little bit more blurred, because chatbots are going to have tools available and they'll resemble more and more of agents. So, just to give you a little bit of foreshadowing what's to come. Now imagine you have an agent that can interact with other agents, and that could be in a linear sort of structure, or that could be in like a group. There could be a manager agent and other agents that are on the crew, and the manager agent has to complete some kind of task, and it may ask different agents to do certain works. Now those works could be done one after the other, or they can do it asynchronously, meaning they're both working at the same time. And so there's all these wonderful, very interesting structures that makes it very exciting and also very disruptive, because arguably a lot of things in business is something that is repeatable. And so once the LLM understands that process, it can continue to repeat it. The other thing that we're going to discuss a little bit later is, when do you use these LLMs under what business situations, and we'll have a little bit of guidance there. Okay, so here's the question: when should you build an agent? And at this point in the course, we just have a little conversation and discussion about that. But for this purposes, we'll just move on. One of the things is, is it a complex decision-making task, right? So workflows involving nuanced judgments, exceptions, or context-sensitive decisions. For example, if you want a refund in a customer service workflow. So if you want a refund for your meal or whatever, maybe you bought something, or you need to go back and forth. Maybe you have to talk about what product it was and when did you buy it, and why do you want the refund. You can imagine that you could use an agent. Notice that the interactions become more and more complex and nuanced, right? So here's a couple of examples. Should we build an agent for this? Yes or no? If we had like customer feedback and we wanted to create a sentiment engine in order to understand if the feedback was positive or negative, would we need an agent to build this? And the answer is not really. You could probably do that with a supervised learning, machine learning model, right? And so that's an example where you're trying to identify a given text, whether it's positive, good for the company, or negative, bad for the company. And then, maybe you want this sentiment engine in order to classify all the negative stuff. And then you go inside and try to understand the topics for sort of the bad reviews or whatever it may be. But in that situation, you don't need one, because you have supervised learning. What about predicting markets? Well, this one's more difficult. Like if you're trying to predict the stock market, obviously there's macro factors, there's political factors, there's geopolitical factors, and also valuation. So that might be interesting to build an agent. A lot of people have tried. No one has successfully created an AI agent to consistently beat the market. Some could argue that Renaissance Technology has, but they don't show or reveal the algorithm, so we're not sure to what extent they're using an AI. But clearly they're using a lot of machine learning, and the students. The employees who work at those top hedge funds definitely have the ability to implement a lot of these AI agents, but we just don't know, because they don't reveal that as part of the proprietary, the nature of trading strategies at that level. What about servicing customers or difficult customers? Yeah, absolutely. You could use an AI agent in order to try to understand the intent and the products and so forth, and maybe the company's procedures for such refunds or whatever it may be, right? So that's a great example. Something complex. How about difficult to maintain rules? Systems that have been unwieldy due to extensive and intricate rule sets, making updates costly or error-prone. For example, performing vendor security reviews. I kind of think about security and vendor reviews and cybersecurity, and the more I think about it, the perimeter is always being attacked. How can you identify when that happens? How can you shore it up? These are things, and I'm sure the attacks come in different ways. I'm not a cyber person, but it feels like any kind of risk and defense could definitely be set up with an agent, where the agent is also learning about the more recent attacks and then trying to figure out if the pattern of the attacks or the systems, whatever it may be internal threats as long as and also external threats, then maybe you could use an agent in order to help identify that. So my gut says that cyber is a field that you could do quite a bit of AI, agentic workflows and creating agents to help identify these patterns, these anomalous patterns that may be attacking your, infrastructure, your systems. We gave some already. What about heavy reliance on unstructured data? So much of the data out there is unstructured. How can you use agents in order to summarize the data, try to understand sort of what's inside, what are the meanings? This is an example where you're using Windsurf and agents in order to try to figure out the folder, the contents, flying blind. It still took some time because the human had to open up the folder, the files, and look at it and try to understand how to read what's inside. And so a lot of common sense was used. In addition to using these AI LLMs in order to figure these things out. But to their example they give is processing a home insurance claim. But there are a lot of things that agents can do that have processes, maybe getting a mortgage or healthcare or paying tuition or whatever it is. Anything that has to touch a lot of systems, and it takes a lot of backwards and forwards in order to understand what's happening is probably pretty good to build an agent. Here's an example, and I'm just trying to map, where's the model? You see the model is in memory and around planning. That's where it's sort of thinking. That's an LLM. Where are the tools? It's under the green bar on the left-hand side. This is where it's reaching out. And then usually a tool has inputs, and it'll go out and find something, and then that will become the output for the tool, and the output is brought back in order to reflect or do something else with that information. Okay. And then for the instructions and the interactions, or think about chain of thought, that's underneath the orange line over there, which is further from planning. Here's an example of an agent. Here we're going to instantiate an agent from the agent class. We're going to call that object weather agent, and inside there we have to give it a name, and then we have to give it instructions. And these instructions are very important because remember, LLMs are looking at text and they're generating text back. So for an LLM to understand what this agent can do, it will look at the instructions. Sometimes they call it descriptions. It says you are a helpful agent who can talk to users about the weather, which is great. And then this agent actually has tools. So what are one of the tools? You can think of it as arms reaching out to the external environment. One of them is get weather. So that's probably an API call to some weather site in order to get the weather there. Okay. Here's another tool. How do you equip the agent with tools? Here, from agent endpoint, agent web search tool and function tool. So this @function tool, this is a declarator. It decorates the function save results. So basically it allows an agent to use this function save results. And in that function, it's a very simple function. You're basically going to take a database and you're going to insert the output. The output consists of maybe the output in that file, but also the timestamp, which is datetime.time. So now for that saved result, you will have the timestamp whenever it's saved. So from line 3 to 5, that is the function that the agent can use. And from line 2, we're allowing it the function underscore tool. Now the agent can use that tool that was written, but you could write any function there and then have the agent below use it. So now look at line 7 through 12. It says search agent is an object from the class agent. The name is search agent, and the instruction is help the user search the internet and save results if asked. So the tools available to this agent are both web search tool, right? Search the internet, and also save results. And save results, as we know, will save the output with a timestamp on it, right? Here's an example of a multi-agent system, but this is a very simple one. Basically, you have one manager. It takes the input, translate hello to Spanish, French, and Italian for me. And so that manages the agent, and it has to route. First it has to identify, what is the task? Is this translated to Spanish, or was it translate this thing to French or Italian? And so given those tasks, it will go and then it will decide which agent to use. Suppose that the request is to translate hello to French, then it will use the French agent in order to do that. So here you can sort of think about the manager as a central manager, and it's coordinating very specific sort of agents to do very specific task, which in this case is translate whatever the input is into that particular foreign language. Here's an example where multiple agents operate as peers, handing off tasks to one another based on their specialization. So here's an example. The input comes in, what is my order? Now this agent is triaging, right? I mean, is this order issues and repairs? Is it based on sales, or is it sort of something that has to do with particular waiting on an order? So here, the triage agent will have to sort of decide what is coming, what's the most appropriate agent to fire up. Is it the issues and repairs agent, the sales agent, or the orders agent, right? So this is an example where you have an agent thinking, think step by step. Given what's happening here, what should it respond? How should it respond? Okay. And then, we're not going to talk too deeply about this, but there's ways to put guardrails, and guardrails ensure agents will stay within, on the road, whatever that means. So, let's see, can you stay on the guardrails of, staying in line of the conversation so you don't go off topic? That would be a relevance classifier. What about safety? So, maybe this is some kind of game for, young people, teenagers, and you don't want it to sort of, go off the rails and start, saying cuss words or being too political, right? Or maybe your agent should not get political at all because it's a very heated political climate, right? So, another one in, I think, like the healthcare organizations, when you generate these reports, is there any PII information in there, personal identifiable information, personal healthcare information? So you can have sort of guardrails to make sure that that's not leaking out of the organization. Also, you could have some agent moderate the conversations. So if there's any signs of hate speech or harassment, then that agent can sort of shut down that user or whatever it may be. Now here are some vibe coding tips from Y Combinator. I encourage you guys to watch that video. It's really good. Here's some summaries of that. What is vibe coding? Just as a review, it's coined by Andre Karpathy. Vibe coding uses large language models to generate code through prompts rather than the manual process. It also generates the results of the code. So it'll run the code, debug errors, and helps you basically create things very quickly in terms of prototype. Some engineers that I've talked to, they say that prototyping is good, but you shouldn't try to put something into production using vibe coding. You should, eventually get a real seasoned human being. What's interesting about vibe coding is you could have a minimal understanding, built by prompts. So you get to see the results. If that makes sense, you could adjust it and sort of, almost as you're building the website or whatever it is, or dashboard, you go back and forth. And you basically don't have to really write code, but you have to talk to it and explain specifically what you're trying to do, right? And individual solo founders can actually, build things in days versus weeks. Whereas in the old days, you'd have to probably talk to your web developer, your front and back end, and all these things, and have multiple meetings. But now you can kind of do that yourself, and that's what's happening out in Y Combinator now. So first off, you start by picking the right tools. Pick tools that are popular. Here's an example of React and Python. And then, there are many different specialized platforms. We're using Windsurf, but there's Replit, there's Cursor, and, I think Claude is going to come up with theirs, and I imagine OpenAI, if they haven't done so. I know there's, I think it's called Codex, and I know they're coming up with their own sort of ways to, write and launch and debug code all in the command line. Okay. The other thing is, before I forget, is that whenever you have agents, it's best if you can break down the task into pieces where the agent can actually work on very specific pieces. For those who get further into this, version control is going to be easy. This is where basically you're putting copies of your code into Git as you develop them. So, some of the advice there is like commit early and often, right? Track AI-generated changes and enable safe experimentation, right? Okay. Right, and maintain meaningful tests. So this is getting even further down the rabbit hole. You want to create safety nets. AI written code may not work as expected. Commit your test code. Founders commit AI-generated tests more often than app logic, and then enable safe refactors. So refactoring is just rewriting your code, and we sort of learned some of the best practices was if the code gets bigger than 200, 300 lines, you should refactor it and sort of break it down, right? And the AI can do that, really well. Here's a few other use cases. We know about debugging and, making documents clearer, more clear, just read well, make it easy to digest. We can also put in documents, as we learned from Google LM, in order to summarize it quickly and also hear podcasts. I think LLMs are great at brainstorming. So, if you have any ideas, you can talk to ChatGPT. Now, you may be training a model behind the scenes, but a lot of times these things are the barriers to entries are basically who's going to do it and work really hard to get it off the ground. What about debugging and avoiding rabbit holes? This is where you're working with your Windsurf and your agent, and basically you get stuck in this loop where it says it's going to go try to fix something, but really it just keeps going back and forth, and you're sort of going down the rabbit hole. And that's a good time in order to shut down that LLM, start or pick a different one, or go back into that folder system with another Windsurf sort of window, and then ask it to sort of understand what's happening here and debugging it. And so debugging is a very key component of vibe coding, and having ways to do that in multiple ways. To fire up a new LLM, I think is important. Okay. What about regular review cycles, and refactoring is also, I think, an important component as you're building these agents out. Keep experimenting, be aware of limitations. So a lot of this development is just basically tinkering with the LLM, seeing if it can do this or do that. Perfect from 0 to 1. Vibe coding excels in initial builds, but struggles with scaling. So, vibe coding is a great way to create some demos and prototypes, but if you want to really scale it, you'll probably need, a cloud architect and, really understand the deployment of clouds and how to scale that, okay? What else is there? Beware of the limitations. Plan for systems engineering. Embrace rapid iterations, but prepare for post-launch architectural needs. So if you're going to put this in production, that's very different than just firing up or prototyping. So that's the point here. It might be at some point, maybe the AI agent just talking to it will create something to production, but we're not there yet right now. Okay. Here are some more tips. Be specific and clear. Use a lot of examples. Remember, 0 shot, you don't put any examples. 1 shot, you put one example. And then, end shots is you put a lot of examples into the prompt. It's always good to break down complex tasks. Break down complex tasks into steps and simpler tasks and have it work on those things. It's good to put down context and constraints of what's going on, what you're trying to accomplish. And then, continue to iterate and refine the conversation. I would probably say that you store it locally and then you can go out, grab a cup of coffee, come back and take a look at it. Just make sure once you store it, you saved it, it's in long-term memory, you can come back to the code and take a look at it and have it sort of re-understand the code base. Here are some other rules of thumb. Use the latest model, put instructions at the beginning of the prompt, be specific, descriptive, and as detailed as possible. Articulate the desired output, start with 0 shot, and then move to 1 shot or few shot. And then for code generation specifics, using leading words to nudge the model forward to a particular pattern. So what does that mean? Well, maybe you want to, do ABC, but it's not getting you there. So then, you could say, I can personify myself this. I want to do this, help me get there. So that's how you could possibly do that. What else? Use the generative anything feature. I'm not as familiar with that. Maybe you can say, hey, try to fix everything and anything. Yeah, okay. Crew AI is probably the easiest way to bring more than one agent into a fold and in a mix to do something. Here's sort of a diagram of how it works. And we know what the agents are. Remember, they're above chatbots. They have tools and they can take actions. And so you can see inside Crew AI, there's 2 agents here. It has sort of memories, which is the state. Also, it has an LLM. It doesn't have to be the same LLM. They can have different LLM, and they can have different tools associated with them. And, both of these agents are trying to complete some kind of task and then share the results and then come out with some kind of final outcome or some kind of goal, right? So that's how it works. Just to recall, these are 2 agents now that are working sort of independently. They can work at the same time. They can work, one and then the other one works, or they can work asynchronously, meaning that when one finishes, it doesn't stop the other one from sort of doing its job. Here's an interesting example. Crew AI Enterprise is a company that keeps innovating, and I created this very simple API, application protocol interface. And so basically that's the waiter that takes information and stuff on the back end and brings the front end, takes stuff on the front end and brings the back end. And it's really easy to build this in Crew AI Enterprise. Okay. What are some of the observations thus far in teaching? I think the AI tech arbitrage is real. Advantages goes to those who know versus those who don't. So knowing and doing, will really set you apart, at least at this particular time in your AI journey and, development of AI as of now. Learning AI is easier than ever. It's basically, if you could interact with a prompt, you can do AI. You have to have kind of a mindset of tinkering, meaning you try a bunch of different things and you don't get, if you don't get the initial result, you can try some more, which is important. I think you also want to avoid any vendor lock. Knowing OpenAI and Anthropic is pretty good. You can know a few more, but I wouldn't have multiple subscriptions out because sometimes you'll forget, and I don't think you need, one getting ahead of the others. OpenAI will catch up within a week or 2, so you don't need like 10 subscriptions. Remember, for the final project, presentation matters. Try to create some really good, designs and presentations and tell your story so you can amplify it. Despite the hype, fundamentals stay the same. AI is a tool solving real-world problems, and you want to add value. And so those are the things. Finally, continue to dig your moat, solve real problems, and keep building sustainable advantages, or just keep building your moat around that. Okay. We'll do that later. Here's your final project. Some of the requirements. You will present 7 to 8 minutes live demo in front of our class on the 8th class, not next week. Next week is a one-on-one meetings with me. And then after that, so in 2 weeks, you'll have your live demo. It must be a working app. During the final class, you're going to actually show what you built. You're going to actually demo it. It must work. You should also send like a 5-minute pre-recorded video 24 hours before that last class. So that we can sort of see that, as always, posted up on the discussion boards. During the presentation, you can use PowerPoints, you can show your app directly, whatever you want, but sort of think about it like a live Y Combinator style demo, but you're going to have to show the app works. The presentation must cover the business problem that you chose to solve, your solution in the app demo. It must work. Lessons learned, what are the challenges that you had to overcome? What are the most difficult technical and business challenges that you faced while you were doing this project? Okay, great. Gamma, I came across this, is really nice. It's a slight fee associated with this, but basically this helps you build PowerPoint presentations really easy. So, feel free to take a look at